Hello everyone, today we'll be finding out that if the earth converts into a black hole, how big it will be. Don't worry, earth is not gonna convert into a black hole, but today we'll be finding out that what is the black hole. Black hole is when anything compresses a lot, so that all mass becomes a small thing that can't be compressed more, and that has intense gravitational pull and intense mass. What if we compress the earth and convert it into a black hole? It will be small, obviously, but how small it will be? It will be like this, or a kilometer big. What? So today we're finding out that we're using a mathematical calculation. So let's get into the video. So the formula is called Schwarz. I can't pronounce that. Schwarzschild Radius, we say it, and it gives us the accurate size of any object when it's converted into a black hole. We'll enter its mass in it, and we get the answer. So first of all, let us know that what is the equation. So the formula is this: Rs is equals to 2gm by c square. Schwarzschild radius is equals to 2 into gravitational constant into mass by square of light speed. So 2 into gravitational constant. First of all, let me let you know that we are calculating it in an approximate value. We're not going very accurate, because when we go very accurate, it will take a lot of space and a lot of time to calculate it. So we are taking an approximate value of g, which is 6.7 into 10 to the power minus 11 Newton meter square per kg square. I know it's 6.6 and something, but we're taking 6.7, and speed of light is 298 and something, but we usually take it as 3 into 10 to the power 8 meter per second, and 2 is a constant. So by using 3 constants and 1 variable, we are gonna find the Schwarzschild radius of the earth. Okay, so let us write all the values. The formula was 2gm by c square. I'm not writing the formula here because it will take some space, and we have a lack of space. It takes a lot of calculation. 2 we will be just deriving its unit later in the video, because now we are just finding the value and we will derive the units later. 2g, capital G. The mass of the earth is 6 into 10 to the power 24 kgs, but we're not writing the units. By c, light speed, c square, so light speed into light speed, like this. Now calculate this. I think 3 twice 3, 2.2 times, and that's it. 2 into 2.2 into 2 into 10 to the power minus 11 into 10 to the power 24. Like this. This is what we got. Now solve this further. 2 into 2.2 into 2, it becomes 8.8. And as we all know in the laws of exponent, that if two numbers have same base and a different exponent or anything, we just add the exponents on the same base. Okay, so 10 to the power minus 11 into, and they are in multiplication, then we add 10 to the power minus 11 into 10 to the power 24. When we multiply 10 to the power minus 11 to 10 to the power 24, it becomes 10 to the power minus 11 plus 24. Minus 11 plus 24, we all know it's 13. So into 10 to the power 13. Same right here, 10 to the power 8 into 10 to the power 8, we can write 10 to the power 16. Further here, So 8.8. And another laws of exponent says that if two numbers are in division and they have same base but different exponents, we subtract their exponents. So 10 to the power 13 by 10 to the power 16, we can write this as 13 minus 16, which is minus 3. So this is what value we get, 8.8 into 10 to the power minus 3. But what is its unit? Is it in kilometers or centimeters or meters? I can say you that yeah, this is in centimeter, and you write yeah, it's centimeter. No, we have to prove that. We have to derive the unit. Okay, so remember this number, this value we got. Everything here is correct. We got this value. Let's go further. Okay, so 8.8 into 10 to the power 3. I wrote the value there because we remember that. And we finally just write the units after that, and it takes a lot of space, so I wrote it in the corner. So what were the components in the formula? 2 g m c square. Okay, 2 is a constant, no any units. G, yeah, G has a unit, Newton meter square per kg square. So mass, so we wrote the mass in kgs. We wrote the earth's mass, which was around 6.6 into 10 to the power 24 kgs. So kgs. C, light speed. As we all know that the light of speed is 3 into 10 to the power 8 meters per second. So light speed square, so we can write meter square per second square. Obviously meter per second into meter per second will result into meter square per second square. Oh, let me erase this. Now, just to write it in a regular way. Newton meter square kg square, it is in division, so it will come down, into kg meter square, second square is in division, so it will go up, second square, this. Now just simplify this. Newton, we all know that what is the value of Newton. The value of Newton is 1 kg meter per second. So we can write Newton as kg meter per second. Now meter square, meter into meter. We are expanding this into kgs. Second into second, 2 seconds. Now here kg square and meter square. Are you getting it? I'm just simplifying it. I'm just expanding it. I wrote Newton in place of Newton. I wrote kg meter per second square. Oh, so it's a square. So we can write one more second here. This kg meter per second square is the value of Newton. Okay, so I know I'm getting out of the frame, but look at it both. Now we will cancel 1 meter, meter, meter. So we cancel this meter with this meter, this meter with this meter, this kg with kg, second, seconds with seconds, seconds, kg with kgs. Everything is just cancelled except meter. Are you getting it? 2 gm by c square, meter square per kg square, m kg. C square is meter square per second square. As it doesn't divide, it will go down to the denominator. So Newton meter square per kg square into kgs and meter square, and it doesn't divide second square, so it will go to numerator. And now I will simplify Newton as kg meter per second square and kg, and this is the kg and the second square, second into second. So as this is kg square, kg into kg, and meter square, meter into meter. Everything is cancelled. In case you guys aren't able to understand it here, I will leave an image of my notebook in the end of the video, so that you can take a screenshot and understand it clearly, because I know it's messy. Okay, so we are getting meter as our unit. So we got this value 8.8 into 10 to the power minus 3 meter. Now we don't want anything in exponent and also negative exponent mainly. So we convert this meter into millimeter. As you know that for converting meter into millimeter, we have to multiply with 1000, which is 10 to the power 3. 8.8 into 10 to the power minus 3 into 10 to the power 3. These both stars base are same. We will add the exponents. Minus 3 plus 3 both will be cancelled. So the answer will be 8.8 millimeter. 8.8 millimeter will be the answer, guys. If the earth is compressed into a black hole, it will be a black hole of radius around 8.8 millimeter. It means the diameter will be around, I think, 17.6 centimeters. Yeah, so it will be just like 17 centimeter, and its radius is 1.5 centimeter. Can you imagine how small is it? And how big will look at the earth. The earth is insane big, and it can be converted to this radius and this size. It's insane. I can't believe it. But we are not here to just measure it. It is a formula, and no one is going to measure it. If the earth changed into a black hole, no one will be just stay to measure that. Okay, it will be changed into a black hole, and I'll measure what is the radius of it. No, because we can find it by using the formula. These formulas are given by scientists, and this formula is on the name of Schwarzschild. So this is the end of the video, guys. You have got that what will be the radius of the earth and how big the earth it will be if it will be converted into a black hole. Okay, so I hope you guys understood of that. I'll give the image at the end of the video after a 5-second long. It is enough to take a screenshot and study of that. Actually, I made notes on it and I wrote a lot in my notebook, but I'll be just pasting this calculation at the end of the video. So that's all. Goodbye.